Hey guys, this is just a quick recap of all the methods we've learned for solving systems so far. So the first one we're going to review is our graphing method. So I'm just going to jot down some notes here to help us with the steps. And when we're graphing, we want our equations in slope-intercept form. Okay, so that's just going to make it easier for us to graph. So for example, if I look at this first equation in the system, it's in slope-intercept form. So I can go ahead and start graphing it. It has a y-intercept of -3, so come down to -3 and put a point. And then my slope is +1/3, so I'm going to go up 1 and over 3. And remember here with graphing, we want our lines to be very accurate for a while. So I'm going to keep that pattern going up 1 over 3. Then I'm going to go the opposite direction, down 1 and left 3 to keep it going this direction. So then I get a nice straight line here that goes through those points pretty accurately. Okay, the second equation we have is not in slope-intercept form. So I need to rearrange this guy. I have 2x plus y equals 4, and we want y equals. So I need to get y by itself here. So what I need to do is get rid of these x's by subtracting 2x from each side. So I have y equals, can't really subtract those because they're not like terms, but I'm going to go ahead and put the x's first so that it's in that mx plus b format, and then I have a +4. Now, that's in the form we're used to graphing. So the other part of this is we are going to graph both equations on the same grid. All right, and what we are looking for is the point where they're going to intersect. So solution is the point of intersection. All right, so this guy, we had a y-intercept of +4. Put a point. And then my slope is -2, or we can think about that as -2 over 1. So from my y-intercept, I'm going to go down 2 and over 1 since it's negative. And again, I'm going to keep that pattern going, down 2 over 1, down 2 over 1, until I hit that intersection point. And I can keep it going past that too, but that is really the point of graphing them on the same grid, is to find that point. So once I have that, that's really the most important part. So this intersection point is my solution, which we're going to write as an ordered pair. So it's at the point 3, -2. So 3, -2 is the solution to that system. So just graphing them isn't quite enough, you guys. Making sure you're actually identifying the point using an ordered pair is required to actually say what the solution is. Okay? All right, our next method here is substitution. And kind of the key idea with this one, I'm going to write my notes kind of over here, is we need one of the variables isolated or by itself in one of the equations. And if it's not, we need to rearrange the equation so that it is. So, and then if we do have one, like we do here, I have y by itself in that top equation, we're going to box in what that variable equals. So here I'm going to box in -x plus 5. And we're going to substitute, hence the name substitution, the boxed in expression into the other equation and solve. Okay, so let's follow that process. So my boxed in expression, -x plus 5 is the same as y. So I have to put it in for y in the other equation, and then we're just going to rewrite that. So I have 2x, but instead of y, we're going to write -x plus 5, and then equals 11. Simplify first if you can. So this is a -1x, so I can combine those like terms and get +1x plus 5 equals 11. And then to solve for x, we just need to subtract that 5 away from both sides to get x is 6. Now, once we find one of our variables, we always need both. So I need to plug my 6 back in into either of the original equations to figure out what y is. So I'm just going to use the top equation. So I have y equals negative x. So x is 6, so that's going to be negative 6 plus 5. Y is already by itself, so we just need to simplify that. Negative 6 plus 5 gives me negative 1. And then our solution we write as an ordered pair. 6 comma negative 1 is that solution. All right, our third method is elimination. So what we need for elimination to work is need x's and y's and constants lined up. So x's plus y equals constant is kind of the form that we want. Okay, and then the other part we need is we need the same coefficient, which remember is the number in front of a variable, so we need those to be the same, but with opposite signs, so one positive and one negative. On either the x's or the y's. Okay, so, and if we don't have that to start, we can multiply the equation, or we might need to do both to make that happen. Okay, so in this one, I'm looking at the numbers in front of my variables, the coefficients. So right now I have a 1 in front of the x, 2 in front of this x. They're not the same and they're not opposite. Right here, I have 1s in front of the y's. So they are the same, but they're both positive. I need one to be negative, one to be positive for that to work. And then the constants don't really matter with what they are. I just need them lined up. So I right now don't have what I need. So we can multiply either one equation or both equations, whatever I need to make it happen. So here we can just choose, do we want to get rid of the y's or the x's? I'm going to choose to get rid of the y's. So I need one of these y's to be negative. So I'm going to multiply my top equation by negative 1. And I'm just going to rewrite that down below here, you guys. So negative 1x, negative 1y, and then negative 2 is what I get for the constant. So I just multiplied everything in that top equation by negative 1. Now I have 1y and negative 1y. So they're the same but opposite signs. So once we have that, we're going to add the equations and solve. So that's why it's very important that your x's, y's, and constants are lined up, because we can only add like terms. So 2x plus negative 1x is positive 1x. And then these are going to be eliminated because they're opposites. And then negative 1 plus negative 2 is negative 3. So actually, we don't even have to do a solving step because x is already by itself. So we got x is 3. We need to substitute 3 back in. I'm going to use my top equation. So we know x is negative 3, and then plus y equals 2. Add 3 here to both sides, and we get y is equal to 5. So my solution is negative 3, 5. All right, so we just reviewed all 3 of our solving methods, but there are a couple things to just keep an eye out for. This can just save you a little time. Reminder that we can possibly have situations where we have more than one solution, like here. Those 3 examples, we just had the one solution. We can also have infinitely many or no solution. So I'm going to talk about what the graphs look like first. So infinitely many. Our one solution is we have 2 lines intersecting at one point. Infinitely many means they're intersecting at every possible point, or in other words, it's just one line graphed on top of the other. So they're going to intersect infinitely many times because there are infinitely many points along that line. Equations are going to look like this. This is just a rough example, you guys. So let's say I have something like this. Okay, so if I look, this top equation is all being multiplied by negative 2. So if you notice that one equation is just a multiple of the other, every single thing, x's, y's, and constants, it's automatically an infinitely many solution problem. So you don't need to even worry about doing the solving step. You can just write infinitely many solutions. So if entire equation is multiplied by the same thing, and the easiest way to tell you guys is when it's in this form, like it's going to be set up for elimination, x's, y's, and then constants. That's when it's easiest to spot the infinitely many solutions. No solution graphically, so this is saying there's no point where the graph would intersect. So in other words, the lines are parallel to each other. They're never going to cross. So that's, if you end up graphing two lines that look parallel, they're never going to cross. And here's what an equation example would look like. I'm actually going to use the same one here. So I have 2x minus 3y equals 1. Negative 4x plus 6y equals 5. So the x's and the y's were both multiplied by negative 2. But here it was multiplied by something different. So they didn't match. Not the entire equation was multiplied by the same thing. So the x's and y's are multiplied by the same number. But the constant is not. So if you see that right off the bat, again, it's easiest to tell when it's in x's, y's, and then constant that form, then it's automatically a no solution problem. All right, guys, that's it for this video. Thanks for watching.